minutes would be too much. So what I would say though is if you have questions about the test tomorrow, that support time would be a great time for you to ask. That'd be a great time. Hey, Mr. Allen, I still don't know how to do this. Okay, so we're going to look at the Pythagorean theorem and its converse. There's the warm-up. We already did that. And so we only have one objective today, and that is to use something called the Pythagorean theorem and its converse. Now, let me refresh your memory on what converse means. So if I have a conditional statement, P arrow Q, remember this is going all the way back, I think, chapter 1. If this is P arrow Q, what's the converse of P arrow Q? Well, it's Q arrow P. You switch the condition and the hypothesis and the conclusion around. So, for example, if I said, if you get A on test, then your, I'll just say mom, will be happy. Would that make your mom happy if you got an A on your geometry test? Maybe, maybe not, I don't know. So what would be the converse of that statement? If you get an A on the geometry test, then your mom will be happy. Well, the converse would be if your mom is happy, then you'll get an A on the geometry test. Then you, oh, maybe I'll say got an A on geometry test. Something like that, right? So I just want to review that because we're going to be talking about a converse here in a minute, okay? Let's go ahead and look at the Pythagorean theorem. This is the most important slide of this presentation. And you guys are probably already familiar with this right here, but I want to make sure you understand what the Pythagorean theorem says. The Pythagorean theorem isn't just a squared plus b squared equals c squared. There's more to it. Here's what it says. If, that's that condition part. If the triangle is a right triangle, key word there is right. If this triangle right here, if it is a right triangle, then a squared plus b squared is equal to c squared. And note, c has to be the hypotenuse. And I know that's kind of a fancy word. We've used it in the past. The hypotenuse is this side right here. It's the side that's opposite the right angle. It's the longest side, if you will. In fact, it will always be the longest side of a right triangle. So let me say it again. If this triangle is a right triangle, then a squared plus b squared is equal to c squared, where c is the hypotenuse. The other two sides, by the way, we call those legs. We call those legs. We already talked about that part. So let's look at an example. You might already know how to do this problem. Now remember, I told you just a second ago to have a calculator handy. Example number 1 says determine the length of the hypotenuse of the right triangle below. Give your answer in both simplified radical form and as a decimal approximation. So let's go ahead and do this. First of all, is it a right triangle? Is it a right triangle? Well, duh, yeah, of course it is. Right there, Mr. Hunt. It's a right triangle. So yes. And if it is a right triangle, guess what we can do? If it's a right triangle, then we can apply the Pythagorean theorem. So since it's a right triangle, now we can go ahead and say this is second. Now we can say that, well, a squared plus b squared has to equal c squared. Remember, c is the hypotenuse. That's very important. You don't want to get that mixed up. A and b are legs. So these are the legs right here. That's a leg and that's a leg. They are the sides that form the right angle. In other words, 6 squared plus 3 squared has to equal c squared. By the way, if you don't like the letter C, you could use X or Y or something else. I'm going to use the letter C if that's okay. So now we got to figure out what C is. Well, 6 squared is 36. 3 squared is 9. 36 plus 9, what would that be? I think that's 45. And that's equal to c squared. So now we have c squared is equal to 45. Now let me just tell you the common mistake that students make here is they'll say, oh, the answer is 45. What did they forget to do? Got to do the square root. Now watch what I'm going to do. I'm going to do this part first, that simplified radical form first. Now, so now I'm going back to algebra 1. This is equal to the square root of 45. By the way, the square root of 45 is the same thing as the square root of 9 times 5. Did you guys know that 9 times 5 is 45? I hope you did. By the way, what's the square root of 9? So the simplified radical form is 3 radical 5. 3 radical 5. So there's our first answer. Now let's go ahead and get our approximate answer. So I'm going to put C approximately. Now here's where I'm going to get my calculator going. I got my calculator going. And I'm going to do the square root of 45. I'm just going to plug that into my calculator, and you can do the same. You can't, I don't think you guys don't know how to find square roots in your head, do you? Anybody know how to do that in their head? Guess what? I don't either. There is a way to do it, but not in your head, I don't think. I'm just going to put that for my approximate answer. Okay? So we've got, this is called the exact answer technically. Mathematicians refer to that as the exact answer, and this would be considered the approximate answer. Oops. This one gives you all the information that you need to know to figure out what that decimal is. I'm telling you, this decimal isn't just those 4 numbers. It goes on forever. It's an irrational number. So we can't really ever write it completely down. So we write it in this more compact way. So does anyone have any questions on that first example? Okay. Virtual people, I really wish I could see some of you. Caleb, Alex, Indy, Ian, Jacob, Grant, Riley. Okay, so example 2. Determine the length of the leg of the right triangle below. Give your answer as a decimal approximation, and this one says to the nearest hundredth. Okay, this one says to the nearest hundredth. Can you guys get this one set up? I want to give you a little bit of a head start. Get it set. In fact, if you want, you can just go and work it out. If you already feel like you know how to do the Pythagorean theorem, that's great. Go ahead and figure out, or at least get it set up. I'll give you a head start. All right, so remember, the first thing that you want to do on these problems is you want to make sure that it is a right triangle. The Pythagorean theorem requires it to be a right triangle. This is a right triangle, so that's good. Now remember, since this is a right triangle, the formula is a squared plus b squared equals c squared, where c is the hypotenuse. Now look here, we already have the hypotenuse. We know that the hypotenuse in this case is 7.4 inches long, or whatever the units are. It didn't really tell you the units. So I'm going to say a squared plus 3.6 squared is equal to 7.4 squared. It is. That's why I put it over there where the C was. Right? Remember, guys, C is the hypotenuse. This is the hypotenuse, so you have to put that in for the C. So this one's a little bit different than the last problem. So now we have A squared plus, and now we've got to do 3.6 squared. Let's see what that is. I'm going to use my calculator. 3.6 squared, which is, I got 12.96. And then I got to do 7.4 squared, which is 54.76. Now I'm going to subtract. I'm going to take the 12.96 and minus that from 54.76. And I think that turns out to be 38.88. Is that right? Is that what you got, Anthony? Oh, no, that's not right, is it? Should that be 41.8?
Yeah, I got
41.8, okay. I think I might have messed that one up. Why don't we check that? Try that again, 41.8. Yeah, that looks like that makes more sense. And so now we're just going to go ahead and do the square root here. In fact, let me go ahead and I'm going to put a little bit of, ooh, didn't mean to do that. I'm going to put an equal sign here, or a kind of a squiggle equal sign. Because now what we got to do is we got to do the square root of 41.8. So I get 6.46529195. Now, guys, that is a decimal approximation, and it is not quite right. So this is. Okay. So now the question asks us to round it to the nearest hundredth. You guys know what the nearest hundredth is for this answer? So here is this is the decimal point. Here's the tenths. Here's the hundredths. Here's the thousandths. So we're trying to round to this decimal here, which is going to give us an answer of 6.47. That is the answer. Now, I'd like to show you something else here real quick with this problem before we move on to the next one. Let me just bring this up. How can you check your answer? How can you check to see if that is the correct answer? Yeah, just substitute. So in other words, what you could do is you just want to see, is this equal, I'll put a question mark, to 7.4 squared. So let's go ahead and check that with our calculators. So guys, anytime you get decimal answers, it's a good idea to check them out. So let's go ahead and see what we get here when we square this. Squared. So when I do the right or the left-hand side here, I got 54.8209. And then on the right-hand side, I get 54.76. Wait a minute. Those don't equal each other. Did I do something wrong? Did Mr. Allen screw up? Say it again, Schmidt. Did we already square what? Yeah, A is this one right here. So I squared that. Oh no, here's A, isn't it? 3.6. That's A. We found this one to be B. I guess I should have switched this around. Does anybody know why those didn't come out exactly the same? I'm hoping someone does. Correct. So Anthony said, Mr. Allen, those aren't going to come out the same because guess what we did down here? We rounded the answer, didn't we? This decimal right here is more accurate than that decimal, isn't it? So if you were to substitute this back up here, and by the way, we rounded this decimal up, didn't we? This 6 right here became a 7, so we rounded it up. So it makes sense that this answer is going to be a little bit bigger than the one on the right. So that's the issue whenever you're dealing with these square roots. So be careful when you check your answer. They're not going to come out exactly the same, particularly if you square a decimal like this. All right, so let's go ahead and move on. All right, next problem here, example 3. Do I have any baseball players in here? Anybody play baseball? Baseball player? Okay. So hopefully you're familiar with the game of baseball. I'll be honest with you, I'm not a big baseball person. I couldn't tell you much about it. I know a little bit about it. I never played it officially, and I'm not a big fan. My brother is, but anyways, this question is about something called a baseball diamond. And this right here, that is a baseball diamond. So let me show you what a baseball diamond is, just to make sure you kind of understand this, and I don't mean any offense. Some of you may not be familiar with what a baseball diamond is. So this shape right here is a diamond shape, and that is why they call it a baseball diamond. Okay, so that's no big deal. But here's what the question says. A baseball diamond is a square with side lengths of 90 feet. What is the shortest distance to the nearest tenth of a foot between the first base and the third base? In other words, by the way, here's first base and here's third base. They want to know what's this distance right there. That's what they're trying to figure out. Now let me draw one additional thing here on my baseball diamond. Let's do it maybe in yellow. Let's see if that shows up pretty good. Oh, that does show up good. Hey guys, you see what shape we just got there? We got a right triangle. We got a right triangle right here. There is a right triangle. Actually, you know what? Before we do this problem, hey, virtual students, I have a poll question for you. In the poll, if you would answer that, I'd appreciate it. We're going to go ahead. Oops, I see a comment here in the chat. Sorry about that. All right. So we have a right triangle. In fact, let me go ahead and draw this. I'm going to draw this right triangle kind of out here to help you guys see it. So we've got this right angle right here, and then we've got the length between first base and second base. This is right here. This is what we're trying to find. Now, right now, this triangle doesn't look very good. Other than the fact we know it's a right triangle, it's going to be kind of hard to figure out what the answer is unless we know something else about the triangle. Does anybody notice anything else about this particular triangle that we would know, besides the fact that it's a right triangle? They tell us it's a right triangle basically because it's a square, right? And squares are formed by 4 right angles. We know that that one angle has to be a right angle. You got it. So up here, remember I mentioned that it said that the side lengths of the square are 90 feet. That means that this is 90 and that this is 90, and we're talking about feet. So that means that this is 90 and then this is 90, okay? So would you guys do me a favor now? I'm going to kind of stop, and I want you to see if you can figure this out to the nearest tenth of a foot. What is, and I'll call this up here, I'll call it C because that's the hypotenuse. Can you find the length of C, please, using the Pythagorean theorem? If you are remotely watching the class today, if you would please complete the poll. I have, looks like 5 people have completed it so far. Anthony, are you still logged in? Krishna, are you still logged in by chance? That's okay. You don't have to log in. It's okay. That's okay. I just was going to ask you a question if you can see something. Okay, so let's go ahead and see if we can figure this one out. So what we want to do here is we're going to use the Pythagorean theorem. So we're going to say that a squared plus b squared is equal to c squared. So this is a, this is b. By the way, it doesn't matter if you switch those around. So 90 squared, I think that might be 8100. Plus another 8100 equals c. So c squared is going to be equal to, I'm assuming that's 162 and then 2 zeros. I think it's 16,200 if I'm not mistaken. And so now we need to do the square root of that. This is where that calculator will hopefully come in handy. And we want to round this to the nearest tenth. And I think it is 127.3 feet. Can anyone confirm that with me? Is that correct? You get that, guys? Okay. All right. So this distance right here from first base to third base is about 127.3 feet. Okay. Oh, by the way, how long would it be to go from first base to second base to third base, like that? Nope. What's this total distance here? 180. You have to do 90 plus 90. Okay, any comments or questions on that? All right, guys, I have just done 3 examples on the Pythagorean theorem, okay? I've done 3 examples on the Pythagorean theorem. They all involve decimals. So I've been trying to make it to where you kind of have to use a little bit of technology. They don't have to be decimals. In fact, I'll talk about something called the Pythagorean triple here at the end. But let's go ahead and move on. Back here we go. Pythagorean triples. All right, now guys, I'm just going to tell you, you're going to have at least one question on your homework about this one. So these are called Pythagorean triples. In fact, let me just show you a Pythagorean triple. You see this right triangle right there? It's got side lengths 3, 4, and 5, agreed? Guess what 3 squared plus 4 squared is equal to? It's 5 squared. So that 3, 4, 5 satisfy the Pythagorean theorem. Let's just double check that. What's 3 squared? Well, it's 9. What's 4 squared? It's 16. What's 5 squared? It's 25. Does 25 equal 1? Of course it does, right? So 3, 4, 5 is what we call a Pythagorean triple. And what a Pythagorean triple is it is a positive set of 3 integers that satisfy the Pythagorean theorem. Another example of a Pythagorean triple is 5, 12, 13. That is also a Pythagorean triple because 5 squared plus 12 squared is equal to 13 squared, because that would be 25 plus 144 equals 169. 169 equals 169. So that's why we call those Pythagorean triples, okay? So on your homework, they may say, hey, is this a Pythagorean? Let me give you an example. Can I give you guys an example of something that's not a Pythagorean triple? So I should have maybe done this in a different, I'll do the purple. This is not a Pythagorean triple. Okay, give me a number, Anthony. 12, fine. Ishmael, give me a number. 5, great. And then I'll pick the next number. This is not a Pythagorean triple. Let me show you why it is not a Pythagorean triple. What is 5 squared plus 12 squared? Does that equal 14 squared? It doesn't. We know that it doesn't because we've already seen this one up here. It had to be equal to 13 squared. So this one is not a Pythagorean triple. Does that make sense? So I'm just going to mention that, and when you get it on your homework, don't get too confused. Just remember that a Pythagorean triple is 3 integers that satisfy the Pythagorean theorem. 3, 4, 5 is the most common one. Okay. All right, so here we go. This is the second most important slide in this presentation, so put a big star next to this one. Remember at the beginning of the lesson, I said that there was going to be a Pythagorean theorem and then its converse. And we talked about what converse is. And converse, actually, you know, before we do this problem here, by the way, on the poll, out of 8 people, 5 got it correct and 3 got it incorrect. That just means that 3 of you weren't really paying attention and taking notes. I just launched another poll, so if you would like to answer that one, I would appreciate it. It's about something we just did a few minutes ago. All right, so now we're going to talk about the converse of the Pythagorean theorem. Try and get that out of the way. So the converse means you take the p and the q and switch them. So for the Pythagorean theorem, it said if it is a right triangle, then a squared plus b squared is equal to c squared. Here's what the converse says, and I've got to let you know, this one's a little bit more difficult, so pay attention. And I'm going to tell you right now, there are 3 parts. There's part 1, there's part 2, and there's part 3. And by the way, I don't care the order, I'm just telling you there's 3 parts. Let's go to part 2 first, okay? Here's what it says. If in a triangle, c squared is equal to a squared plus b squared, by the way, guess what that looks a lot like? Looks like the Pythagorean theorem, doesn't it? If c squared, that's the long side, is equal to a squared plus b squared, then it's a right triangle. And you guys might think, well, duh, we just did, I know, but remember, we're taking the p and the q part, switching them around. Now let's go back up to number 1. This is where things get a little bit more interesting. If c squared is less than a squared plus b squared, it's an acute triangle, which means all the angles are less than 90. In fact, let me write that down. Acute means all 3 angles are less than 90 degrees. So if I give you 3 numbers, and it turns out that the longest number, the biggest number, is less squared, is less than the other 2 numbers squared added together, it has to be an acute triangle. And now let's go down to our third part of the converse of the Pythagorean theorem. It turns out that if c squared is greater than a squared plus b squared, if it's greater, then it is an obtuse triangle. By the way, an obtuse triangle has 1 obtuse angle. And remember, obtuse is not bigger than 180, bigger than 90. Sorry about that. An obtuse angle is one that is greater than 90 degrees. Now, guys, I just went through this. I'm not sure that, guys, I only had 2 people complete that poll. I appreciate you to answer that poll. Let's go ahead and just look at some examples of the converse of the Pythagorean theorem, and I think it should make more sense. Okay? Now, remember, this is important. In fact, let me write this in here in green. Remember, C is the longest side. Remember we talked about that at the beginning of the lesson today? The C has to be the longest side. So let's look at our first example here. Let's look at example 4a, right here, this one right here. It says determine if each triangle is a right triangle. Now, in order to do this, we got to remember that in order for it to be a right triangle, that the c squared has to equal the a squared plus b squared. So first of all, what's c in this problem? Well, it's 15, agreed? So we need to figure out, is c squared question mark a squared plus b squared? That's what we got to do. Hopefully it'll be equal, and then if it is, then it's going to be a right triangle. So c here is going to be 15 squared. A is, well, I'm just going to let 12 be a, it doesn't matter. And then b is going to be 9. So let's see if those things are equal. I'll put a question mark. In fact, let me do my question mark in a different color here just to make it stand out a little bit. Question mark. question mark. Okay, so 15 squared, I think that's 225, if I'm not mistaken. 12 squared is 144, and 9 squared is 81. So what is 144 plus 81? I'm not sure. I'm going to take my calculator. I just want to make sure that I get that right. 144 plus 81, it's 225. And by the way, is 225 equal to 225? Of course it is. So yes, this is a right triangle. Now guys, I don't know if you're catching what we just did here. What I'm telling you is, even though this, by the way, this looks like a right triangle, doesn't it? This one does too, but we're going to find out if it is or not. The converse of the Pythagorean theorem allows us to classify triangles. So what I'm telling you is if I didn't tell you that this is a right triangle, it doesn't matter, because by the converse of the Pythagorean theorem, we can see that it is. Now let's go ahead and do part B over here. I'll do this one in a different color. By the way, you guys might not know this, but did you guys know that C here is going to be 11? And I'm telling you that it's 11, or that's the C, because I'm telling you that this decimal right here, if you plug that in your calculator, it's less than 11. It's 10 point something, right? So let's see if this one is a right triangle. So we've got to do the following. We've got to say, is C squared, how does that compare to A squared plus B squared? And I'm going to put, again, I'm going to try to use different colors here. We got to figure out what we're going to put in the middle there. We hope that it's equal, but we don't know. So let's go ahead and do the math. Again, you might want to keep your calculator handy. So we need to do 11 squared, and then I'm just going to do 9 squared. And then on this last one, watch how I write this. I'm going to do the square root of 115 squared. I'm going to write it like that. Put my question mark in the middle. All right, so what is 11 squared? I think that's 121. Again, if you don't know that, just use your calculator. 9 squared, everyone knows that, I think. That's 81. Now, the square root of 115 squared is 115. Now, guys, I hope it doesn't take you too long to figure out that these two things are not equal. Agreed? So you're going to end up getting, on the left-hand side, you got 121, and on the right-hand side, you've got, what is that, 196? I do that addition right? You guys would agree that those are not equal, right? So is that a right triangle? Nope. Nope. It is not a right triangle. In fact, does anybody know what kind of triangle it is? It has to be an acute triangle. We'll get to that on my last example, though. Okay? So far, so good? Makes sense? So we're still doing the Pythagorean theorem. All right, this is my last slide, I believe. Slide, example number 5. And here's what I'd like you guys to do. I'm actually going to let you try this one here. I want you to try A on your own, and I'll do B for you. But I'm going to come back here to this important slide right here. If C squared is less than A squared plus B squared, it's acute. If C squared is equal to A squared plus B squared, then it's right. If C squared is greater than A squared plus B squared, then it's obtuse. That's what you're going to use now. So you need to figure out, is this one right? Is it acute? Or is it obtuse? It's one of the three. So try to find that out on your own, and I'm not even going to give you any hints. All right, so I've kind of left you guys to try A on your own. Does anybody have an answer? I'm going to speak specifically to you guys in virtual land. Okay, I have an answer of an acute triangle. So one person said acute. Okay. Anybody have any other answers, or are you guys still good with that one? Ooh, I have someone that says obtuse. Any other answers? Anybody get right? Okay, nobody got right. So let's work it out and see. So here's what we got to do. First thing you need to do is recognize that C has to be the longest side. So C is 17. So we've got to figure out, is 17 squared, 12 squared plus 9 squared, and we got to figure out what this is going to be in the middle. Is it going to be equal? Is it going to be less than? Is it going to be greater than? What's it going to be? So now, guys, this is where for some reason, I can never remember what 17 squared is. It's 289. So this is 289, and then this is 144, and then this is 81. I'll put the question mark there in the middle still, so I'm not sure what the relationship is. And then I think we just did that one, didn't we? Yeah, then that 225. So we got 289 and then 220. This is greater than. This is greater than. So when I come back here to this slide, if it's greater than, it is obtuse. So I'm telling you that this is an obtuse triangle. And we use the converse of the Pythagorean theorem to determine that. It is an obtuse triangle. Even though the triangle looks like a right triangle in the picture, it's not. It's an obtuse triangle, which means this angle right here is greater than 90. It's greater than 90 degrees. In fact, that was like 790. That's not a good way to write that. I'll put 90 plus. It's 90 plus degrees there. It's not 90, it's more than 90, okay? Let's go ahead and do part B here on this last one. That'll bring us right to the end of our 60 minutes. And then we'll talk about what you guys need to do for your support time. So let's go ahead and do the same thing here. First thing you want to do is recognize C has to be the longest side. It has to be that 20.1. 20.1. So we're going to do 20.1 squared, 9.6 squared, plus 18 squared. And we want to know what that relationship is. Now this one's a little bit harder because I got decimals. No biggie, I'm just going to use my calculator. Some of you may be using the calculator all the way along, and that's fine. So that's 401.01. 9.6 squared is 92.16. 18 squared, I do not know what that is. There it is. 324. And again, I don't know what that relationship is. I'm about ready to figure it out, though. So I'm going to add those two things on the right. And I get 416.16 compared to this 404.04, which is less than. So this is a huge triangle. Now, guys, one final comment here about this converse of the Pythagorean theorem. On the converse of the Pythagorean theorem, you do the c squared and then the a squared plus b squared over here. So this is on the left, and this is on the right, right? So it's either equals, it's greater than, it's less than, but you do the hypotenuse on the left, and the a squared plus b squared on the right. Now I'm going to go ahead and stop recording here because we got the content taken care of now. And this brings us pretty much to the end